Good morning or afternoon, all. It is now Thursday, April the 16th. So here is your warm-up for the day. And I'm actually not going to go work through all this, namely to save time on the video. But if you wanted to practice on your own, I'm going to go ahead and give you the answers. So this one actually intersects in 3 different places at -9, -6, -6, -9. That's interesting. And -6, -3. So on this one, just to get you started, you can see that your y squareds cancel and your 12y's cancel. So go through and add them together, solve for your 2x values, which you can see is -6 and -9, and then plug those back in and solve for y. So you can work through that one on your own. Today we're going to actually, again, a day of review. So we're going to graph some inequalities and some linear equations. Just a reminder that Mr. Abundis is actually teaching this same class with me. And he is the calculus teacher. So all of these things that he's come up with for concepts and units are all leading you into things that will help you in his calculus class at some point if you end up taking it. So you may not think they're important, but if you're planning on taking calculus, then they actually are very important. All right, so this is back from Algebra 1, just to graph these 2 lines. So for this one, I'm going to use the y-intercept and the slope. So I have a y-intercept of -3 and a slope of 3/2. So that means up 3/2, up 3/2, so on and so on and so on. So my graphs may get a little messy just because I'm trying to do these on Smart Notebook. All right, so for this one right here, there's a couple ways you can do it. I like to choose my intercepts, my x-intercepts, if at all possible. So I look for my x-intercept and my y-intercept, which is going to give me 2 points on the line, and then I can connect them. Some of you in the past 36 years of teaching always insist on changing to y = mx plus b. So if you choose to do that, go ahead, but you are just setting yourself up for a little bit more error in transferring that equation. So as far as intercepts go, this one's pretty easy. If I make x = 3, then y has to be 0. And then if I make x = 0, then I have -y = 9, so y has to be -9. So my y-intercept is 0, -9. So it's very easy to graph like that. I have 2 points. All you need is 2 points that determine a line. So this is going to be not too bad. Okay, so then you can see from here, graphing is usually not your chosen method to solve, but it looks like this is intersecting at the point 4, 3. So graphing is not your chosen method, but that is an important point in the world of calculus. It's called a constraint. So if you would have insisted on changing this to y = mx plus b, I would move my y to the right, my 9 to the left. So I get 3x minus 9 = y. So then you can see that you get the same y-intercept. And then if you keep counting your slope, you're going to end up on this point right here. All right, so just a little review of graphing 2 lines. So now we're going to throw in the inequalities. So if you want to copy this slide down, you might want to pause it and just copy it. And then maybe restart it and just listen quickly. So we're going to be graphing the boundary lines. Remember, you have a solid and a dashed line depending on the inequality. The way I choose on how to shade is I use a test point, and then I determine true or false, and either shade over that test point or the other side. Since these are going to be systems of inequalities, you're going to look for shading overlap, which is going to get a little messy for me today. And then if you want to check, all you have to do is pick a point in the shaded solution set and check in all the original inequalities. Okay, so you've been through this before in Algebra 1, Algebra 2, and probably college algebra. Okay, so I've got a couple inequalities here. So on this first one, 3x plus 2y, when I shade my boundary line, I go ahead and change it to equals -2. Okay, so on this one, I'm not going to use intercepts, mainly because of the 3. I guess it wouldn't be too bad. I'm going to go ahead and change this one to y equals mx plus b. So 2y equals -2 minus 3x. Y equals -1 minus 3 over 2x. Okay, so that's my boundary line, and I have to remember that it is solid. Okay, so y-intercept of -1, down 3, 1, 2, 3 over 2. So this boundary line solid. Whoops. There's going to appear something like this. If I was doing this on paper, I'd be using a ruler to make sure those lines were straight. So 3x plus 2y equals -2. Okay, so for this one, I'm going to choose to use intercepts. So x plus 2y equals 2. So if I make x equal to 2, y is equal to 0. If I make x equal to 0, y is equal to 1. So 2, 0, 0, 1. Again, this is a solid because of the or equal to. I'm not doing too bad on my lines here. All right, so I should have probably determined my shading before I drew that second line. So I'll go to a different color. So on this one, the first one right here, neither one of those lines go through 0, 0. So 0, 0 is a good test point. So if I would plug 0, 0 in here, I get 0 greater than or equal to -2, and I know that's true. So for that black line, I would be shading this side. This is where it's going to get messy. So for my second line, it doesn't go through 0, 0. So if I plug 0 in here, 0 in here, I get 0 is less than or equal to 2, which is true. So I would be shading below that red line. So my overlap solution set sits in between these lines. So using OneNote, this is going to get a little messy, but you just have to do your best to make it look nice for me. Okay, so if you wanted to check, pick a point down there in the solution set. Actually, you can just pick 0, 0. 0, 0 works in both of them, so that tells you that you have shaded correctly. When you are checking your test point and your solution set point, make sure you use the original inequalities that are given to you in the problem. Those haven't been manipulated by the problem solver at all, so you know those are still in the correct form. All right, so this next one, we're looking at 3 different inequalities, so this one could get really messy. Okay, so this first one, I'll do this one as black. It's going to be a dashed line. So I have x minus 2y boundary line equals -7. I don't like that -7 there. So I'm going to go ahead and change this one to y equals mx plus b. divide by -2. So I get 7/2, which is 3.5, plus 1/2 x. So this one will be a little bit sticky just because of the fractions that you have to deal with. All right, so y-intercept is 3.5. And I have to go up 1 and over 2. Up 1 and over 2. So that one's not too bad. I'm kind of impressed with myself with my neatness right now. Okay, so I would pick 0, 0. So if I do 0 minus 0 less than -7, that is false. So I would be shading above that line. This is where it's going to get messy. For my second equation, I'll go ahead and do this one in red. It's an or equal to, so it'll be a solid line. So I have 2x minus y equals 4 is my boundary line. So this is an easy one to do intercepts. So if I make x equal to 2, y is equal to 0. If I make x equal to 0, y has to be -4. So again, if you insist, you can change that to y equals mx plus b. So I have 2, 0, 0, -4. This one is solid. So I can use 0, 0 on this one too. So 0 minus 0 less than or equal to 4, that's true. So this one would be shaded above. So right now my overlap is above that dashed line. Just kind of need to keep a visual on that one. All right, so third equation. This one is going to be dashed. So I have x plus y equals 2 as my boundary. So 2, 0, and 0, 2 to make it nice and easy. So there is a constraint point. And 0, 2 is right here. So this one is dashed. So 0, 0 in this one, 0 plus 0 less than 2, that is true. So this blue would be shaded everything below. So you can see your overlap where the blue and the black and the red all intersect. So that is just in this area right here. So it's also a good idea to label your lines. I know when you look at solution manuals or solution sets when you're in college, all of your lines are labeled in the solution manual. So then I would probably pick a point in the solution, maybe right here. So that would be probably about -8, 0. Check it in all 3 of these equations just to make sure it works. And I believe it does. All right, let's see if I can stay neat on this last one. Okay, so again, 3 of them. So for the first one, this is going to be a dashed line. 3x minus 4y equals 8. Probably go ahead and solve it for y. Divide by -4, I get y equals -2 plus 3/4 x. So -2 here, and then up 3 over 1, 2, 3, 4. So this one is dashed. Go ahead and label the lines for this example. So you can test your 0, 0, and 0 is less than 8. That is true. So you would be shading this side of that dashed line because 0, 0 makes that statement true. Okay, so this one is a simple horizontal line at y equals 5. So 1, 2, 3, 1, 2, 3, 4, 5, and it is dashed. Okay, so you can test 0, 0 there. So 0 less than 5, that is true. So you would be shading all of the values below that line. So you can see your overlap right now is in this little angle sliver right here. So for this last one, it's actually already in y equals mx plus b form. I'm going to go back and label this y equals 5. So I have a y-intercept of 7, 2 units above the 5, down to over 1, down to over 1. And this is solid. This one looks really messy. So if I plug 0, 0 in for that one, I get 0 plus 7 less than or equal to 0. 7 is less than or equal to 0. That is false. So I don't want to shade over 0, 0. I would be shading away from 0, 0. So you can see your overlap is basically in this little triangle right here. So if you wanted to check to make sure, choose a test point, maybe something that's right in the middle right here. Or would that be 1, 2, 3, 4, 1, 2, 3? Plug it back into all 3 of these inequalities and make sure it works. Okay, so one thing, when you're in the world of calculus, these points where all of these intersect right here are going to be rather important for you. Okay, so this one, these are going to intersect out here. So these points are called constraint points. They're easy to find because you just solve each system separately with 2 systems. We don't go that far into it in this class, but that's kind of where this is headed. So you're looking for the constraints. Okay, so there is no assignment today, but tomorrow I have a short assignment just covering the last 3 days, and by short I mean 5 complete total problems. So I don't think that's going to put you over the edge. I've set this week up for some of you to get caught up, so hopefully that's helping. So I'm going to go ahead and put the worksheet in the folder just in case those of you who are caught up want to go ahead and get it done and not have anything to do on Friday. So I'm always available for Zoom meetings. If you're having trouble with something, just shoot me an email and I'll find a time that works. So tomorrow, Friday's a work day. Everybody have a great weekend. I'm here for you. You just have to reach out.